to talk about titration problems of polyprotic acids. So we've already done titration problems with monoprotic acid, but we also want to keep in mind diprotic acids and triprotic acids. You guys know that for titration problems, you're using the formula MAVA is equal to MBVB. We use this formula, it's at the equivalence point of a titration, and it tells us the point where moles of acid is equal to moles of base. So the reason why this is going to be slightly different is because when you put in a triprotic or a diprotic acid, it's going to donate more hydrogen ions than a monoprotic acid would. So when we're figuring out our molarity, we have to think about, okay, if I put in this acid, the moles of my hydrogen is actually going to be more than if I just put in a monoprotic acid. So that's what we're going to keep in mind when we do these problems. So the example problem that I have up here says, what is the molarity of phosphoric acid if 25.0 milliliters is titrated with 35.0 milliliters of a 0.15 molar sodium hydroxide? So the first thing that we're going to have to do is write out our equation. So we're going to have H3PO4 plus sodium hydroxide. And this right here is an acid plus a base, so we know it's a neutralization reaction. So it's going to form Na3PO4 plus water. So we have to make sure to balance out our reaction. So we have 3 sodiums on this side, so we need 3 on this side. Then we're going to have to add a few more waters, so we're going to put a 3 right here. You know you're going to be doing this additional step if when you write out your reaction, you need to balance it. So what we're going to do is we're looking for the molarity of phosphoric acid, so that means we're looking for Na. So we're going to solve it like we normally do to start off. So I have Na is equal to MbVb divided by Va. So my molarity of my base is 0.15 molar. My volume of my base is 35.0 milliliters, and that's again of my base, divided by the volume of my acid, which is 25.0 milliliters of my acid. And if you'll just get a calculator and go ahead and solve that. It should come out to 0.21 molar of my acid. Now this molar value is saying that we just have a monoprotic acid, but we don't. We have a triprotic acid. So our molarity of our acid is actually going to be slightly different. So what we're going to do is we're going to start with the molarity that we just solved for. We're going to do a little conversion factor. So if we have moles of A on the top, we're going to want moles of A on the bottom. And we're going to put moles of B on top. Whenever we have moles over moles, you guys know that we are using the coefficients out in front of our substances. So we have 3 moles of B is needed for every 1 mole of A, because here we have 3 hydrogens, but if we didn't balance this, we would only have 1 hydroxide, so we have to make sure we make it equal. So if you want to go ahead and finish this problem, you should get a molarity of 0.63 molar of H3PO4.